Suppose you have two electrons. Let's say one is placed in Paris and another is shot out to Uranus, 3 billion kilometers away. And what if I told you that when we observe the electron on Earth, we would instantly know the state of the electron on Uranus? This is due to a phenomenon known as quantum entanglement. Electrons exist in one of the two possible states, spin up or spin down. But at the quantum level, particles like electrons don't spin in the conventional sense of classical mechanics. Instead, they can exist in a state of superposition where the electron is a combination of the two states. This is easily understood by a thought experiment introduced by Erwin Schrodinger. In this experiment, a cat, a flask of poison, a radioactive source, and a detector is placed into a sealed box. At random chance, the radioactive source will begin decaying. Here, Schrodinger presents two possible outcomes. 1. The source can decay and trigger the detector, shattering the flask of poison and killing the cat. 2. The source will remain undecayed and the cat survives. Because this is a random process, we have no idea of whether the cat is alive or dead until we open the box to verify. This is why we can say until we open the box, the cat is in a state of superposition, where it is both alive and dead. Similarly, an electron is constantly in a mixture of the two spin states, and it only collapses into one definite state when we make an observation. But how exactly do particles become entangled? Let's say a system has a total spin of 0, or no angular momentum. When this system is split into two, due to the conservation of angular momentum, the total spin must add up to 0. This means that the spin of one electron is directly linked to another. For example, when we measure one entangled electron to have spin up, we will instantly be able to figure out that the other electron will have the opposite spin, so they can cancel out and equate to the total spin. And this case of quantum entanglement can take place over indefinite distances, whether that be between Paris and Uranus. If we observe the electron on Earth to have spin down, the electron on Uranus will instantly collapse into spin up. And Einstein described this phenomenon as spooky action at a distance, as entanglement implies instant communication faster than the speed of light.